paper production begins with raw logs delivered to the mill. Logs are transferred by conveyor for surface preparation. Bark is removed to prevent contamination during pulping. Removed bark is collected separately for reuse or disposal. Cleaned logs are prepared for size reduction. Logs are fed into chippers to produce uniform wood chips. High-speed blades cut logs into controlled-sized chips. Freshly cut wood chips move toward screening. Screening ensures consistent chip size for pulping. Oversized chips are redirected for resizing.
Uniform chips are stored temporarily before pulping. Sensors maintain a steady supply of chips.
Chips are released in controlled quantities for pulping.
Heat and chemicals break down wood fibers.
Controlled mixing ensures uniform pulping. The pulped fiber mixture exits the digester.
Pulp pressure is reduced in the blow tank.
Excess steam is safely released from the pulp. Water is added to control pulp consistency. The prepared pulp moves toward cleaning and screening. Unwanted particles are removed from production. The cleaned pulp is ready for further refinement. The pulp enters fine screening to remove remaining contaminants. Vibrating screens filter out small, unwanted particles. Clean pulp continues forward while rejects are removed. Centrifugal cleaners use rotation to remove heavy contaminants. Heavy particles are separated from the pulp stream. The cleaned pulp exits the centrifugal cleaners. Secondary screening further improves pulp purity.
Pressure screens remove fine contaminants and fiber bundles.
Only clean fibers pass through precision screen slots. Rejected material is removed to protect paper quality.
The cleaned pulp moves into thickening for consistency control. Excess water is removed to adjust pulp concentration.
Water drains away while fibers remain. The pulp exits at a controlled consistency. Sensors continuously monitor pulp consistency.
Automatic controls fine-tune water levels. The pulp is collected in a blending chest. Agitators keep fibers evenly mixed. Process water fine-tunes the pulp mixture.
Samples are taken to verify pulp quality.
Approved pulp continues toward sheet formation. Rejected pulp is sent for reprocessing. The clean pulp moves toward the paper machine. Flow controls ensure even pulp delivery. The pulp is now ready for sheet formation.
The cleaned pulp enters the head box for sheet formation.
The head box spreads pulp evenly to control sheet thickness. Water begins draining as fibers settle on the wire. Fibers interlock to form a continuous paper sheet. Cable rolls support the wire and improve drainage. Coils enhance water removal and sheet formation. The sheet gains strength as water content decreases. Edge trimming controls the final paper width.
Excess fibers and water are removed from the edges.
The forming sheet becomes visibly uniform. Top wire pressure improves fiber bonding. Remaining free water is removed by suction. Windowed by suction. The sheet reaches its target forming consistency. The wet sheet transfers smoothly to the press section. The press felt supports the sheet for dewatering. Alignment controls prepare the sheet for pressing. Moisture sensors monitor sheet uniformity. Vacuum levels are adjusted automatically. The sheet gains stability before pressing. Recovered water is returned to the process. Sheet speed is synchronized with downstream sections. Final forming adjustments ensure consistency. The paper sheet enters the press section. Press rollers prepare to remove more water. Mechanical pressure removes additional moisture. Water is absorbed into the press felt. Sheet forming is complete and pressing begins. The wet paper sheet enters the press section for mechanical dewatering. High-pressure rollers squeeze water from the paper sheet. Press felts absorb water removed from the sheet. Felts transport extracted water away from the sheet.
After the first press, the sheet contains significantly less water.
The sheet transfers smoothly to the next press stage. Additional pressure removes more moisture. Pressing increases sheet density and strength. Extracted water is collected for recovery.
Press felts are continuously cleaned for efficiency.
A final press further reduces moisture content. Pressing stabilizes the paper sheet structure. The sheet exits with a uniform moisture profile. Sensors verify moisture levels before drying.
Press pressure is adjusted automatically to maintain quality.
Mechanical pressure raises the sheet temperature slightly. The sheet moves from pressing to thermal drying.
Dryer cylinders prepare to remove remaining moisture.
Heat begins evaporating remaining water from the paper. Steam heats the cylinders to dry the paper sheet. The sheet wraps around heated cylinders for uniform drying. Moisture evaporates as heat transfers to the sheet. Dryer fabrics guide the sheet through the drying section. Tension controls prevent sheet breaks. Multiple cylinders gradually dry the paper.
Moisture content decreases step by step.
Exhaust systems remove humid air from drying. Drying strengthens fiber bonds within the paper. Drying strengthens fiber bonds within the paper.
The paper exits the drying section.
The dried paper is ready for reeling. The dried paper sheet enters the reeling section. The paper sheet is wound onto a large reel. Reel speed is synchronized to prevent sheet breaks. The paper roll builds gradually during winding. Edge trimming ensures clean and uniform rolls. Trim waste is removed for recycling. Roll dimensions are monitored precisely. Automatic systems prepare for reel change. The finished jumbo roll is separated from production. The roll is secured for safe handling. The jumbo roll moves to the winding section.
The roll is mounted onto the winder machine.
The paper unwinds for precision cutting. Slitting knives cut the paper to required widths. Multiple rolls are produced in a single operation. Tension control ensures smooth roll formation. Uniform winding prevents defects. Each roll reaches its specified size. Finished rolls are separated automatically. The finished rolls move toward inspection. Product labels are printed for identification. Each roll is labeled for traceability. Roll weight is checked to meet specifications. The approved paper roll continues forward without any change in material or quality. Non-conforming rolls are removed. Protective wrapping prevents damage. Rolls are stacked for storage and transport. Pallets are transferred to warehouse storage. The finished paper is ready for distribution.
Here we see the raw cotton being fed into the massive looms, a continuous process where thousands of threads are woven together at high speed. Fabric production begins as compressed cotton bales are opened, allowing the fibers to loosen for further processing. Fabric production begins with raw cotton bales delivered to the factory floor for initial handling.
Forklifts transport tightly compressed cotton bales to the opening area of the production line. Each bale is positioned precisely to ensure a smooth and controlled feeding process. Protective coverings are removed to expose the raw cotton fibers for processing. The bale opener gently breaks apart compressed cotton to restore fiber volume. Loosened cotton fibers are evenly distributed onto a conveyor for consistent flow.
Several bales are processed together to maintain uniform fiber quality.
Automated sensors regulate the cotton feed rate to prevent overloading. The fibers move into the opening chamber, where further separation begins. Rotating beaters break down fiber clumps into smaller, manageable sections. Loose dust and surface impurities are released as fibers are opened. Powerful extraction systems remove dust to maintain fiber purity and air quality. Cleaned fibers are transported toward the mixing section for uniform blending.
Blending fibers from multiple bales ensures consistent fabric quality.
Control systems precisely adjust blending ratios for uniform results. Airflow systems gently transport fibers without damaging their structure.
Secondary opening further separates fibers for improved alignment.
Precision rollers refine fiber separation while maintaining length integrity.
Remaining impurities are removed and collected for disposal.
Quality sensors monitor fiber consistency in real time. Prepared fibers are temporarily stored to balance production flow. Level sensors ensure a steady and uninterrupted supply to the next machine.
The opened and cleaned cotton fibers are now ready for carding. The carding process begins as opened cotton fibers are fed into the carding machine.
Feed rollers distribute fibers evenly to ensure consistent carding. The main carding cylinder uses fine wire teeth to separate and align fibers.
Cotton fibers are lifted and spread to remove tangles. Flat bars further comb the fibers, improving alignment and cleanliness. Extraction systems continuously remove unwanted particles from the fibers. Cleaned and aligned fibers move toward the Doffer cylinder. The Doffer cylinder gently lifts fibers from the carding surface. A thin, continuous web of fibers is formed after carding. The fiber web is condensed into a soft, rope-like sliver. Combing begins as slivers enter the combing machine. Combing rollers straighten fibers to improve yarn quality. Fine combs remove remaining short fibers and imperfections. Short fibers are separated to enhance strength and uniformity. Only long, high-quality fibers continue through the process. The refined sliver moves steadily toward collection. The carded and combed sliver is now ready for drawing. Drafting rollers rotate at varying speeds to stretch and equalize the sliver.
Several slivers are combined to improve uniformity and consistency.
The sliver becomes thinner and more uniform during drawing. Sensors continuously monitor sliver weight to maintain quality control. Automatic controls fine-tune drafting speeds for precise results. The equalized sliver exits the drafting zone smoothly. The sliver is gently condensed to stabilize its structure. The drawn sliver coils evenly into collection cans. Roving begins as drawn slivers enter the roving frame.
The sliver is further stretched to reduce thickness.
A slight twist is added to give strength to the roving. Tension controls ensure smooth and stable roving formation.
The roving is wound evenly onto bobbins for spinning.
Multiple bobbins operate together to maintain production speed.
Finished roving bobbins exit the machine, ready for spinning.
Roving bobbins are organized for efficient transport.
The roving is transferred to the spinning section. Operators visually inspect roving quality before spinning. Only approved bobbins proceed to the spinning stage. Only approved bobbins proceed to the spinning stage.
The prepared roving is now ready for yarn spinning.
Yarn spinning begins as roving bobbins are loaded onto the spinning frame.
Tension guides control the roving flow before drafting.
Drafting rollers stretch the roving to achieve the required yarn thickness. The roving is drawn out to form a fine, even strand.
Twist is applied to bind the fibers together into yarn. Continuous yarn formation takes place at high-speed spindles.
Hundreds of spindles operate together to maintain production output.
Balloon control rings stabilize yarn movement during spinning. Automatic lubrication reduces friction and machine wear.
Finished yarn is wound evenly onto bobbins.
Sensors monitor tension and speed to ensure yarn quality. Stop-motion systems immediately halt spindles when breaks occur. Broken yarn ends are quickly repaired to minimize downtime.
Production resumes immediately after repair. Bobbin filling continues steadily during spinning.
Spinning frames run continuously to meet production demand. Air suction systems remove lint to keep machines clean.
Inline sensors check yarn thickness in real time.
Operators monitor machine parameters to maintain quality.
We have always made for air.
Bobbins are filled to a preset diameter for consistency.
Automatic doffing prepares to remove completed bobbins.
Completed yarn bobbins are removed from the spinning frame.
Empty bobbins are placed to continue spinning without delay.
The spinning cycle resumes immediately for uninterrupted production.
Finished yarn bobbins move to the winding section.
Conveyors transport yarn efficiently within the factory.
Bobbins are grouped for traceability and quality control.
Each batch is tagged for tracking through later processes.
Temporary storage balances spinning and winding operations.
Yarn samples are taken for quality testing.
Strength testing ensures the yarn meets specifications.
Approved yarn bobbins proceed to the winding process.
Any defective bobbins are separated from production. Quality-approved yarn moves toward winding.
Bobbins are mounted onto winding machines. Winding machines start preparing yarn for weaving. Yarn ends are threaded to begin winding.
The spun yarn is now ready for fabric production. Warp yarn packages are mounted onto the creel to prepare longitudinal threads.
Tension guides align warp yarns for controlled feeding. Pedals control the vertical movement of warp threads. The reed maintains spacing and alignment of warp threads. Weft yarn is positioned to interlace with warp threads.
The loom begins operation by opening the shed.
The reed beats the weft yarn firmly into the fabric.
Interlacing of warp and weft forms the fabric structure.
Newly formed fabric advances steadily during weaving.
The weaving cycle repeats continuously for uniform fabric.
Edge guides maintain consistent fabric width.
Tension sensors ensure even fabric formation.
Broken yarns are repaired immediately to resume weaving.
The fabric roll builds steadily during operation.
Continuous inspection ensures surface uniformity.
Fabric rolls are produced to precise length specifications. The loom slows as the fabric roll nears completion. The finished fabric roll is separated from the loom. Fabric rolls are secured to protect material integrity. Each roll is labeled for tracking and quality control. The fabric roll is positioned for detailed inspection.
The finished fabric roll is mounted onto the inspection machine. The fabric is unrolled at a controlled speed for inspection.
Special lighting highlights surface defects and irregularities.
Operators visually inspect the fabric for defects.
Magnification helps identify fine surface imperfections. Detected defects are marked for quality grading.
Fabric advances steadily through the inspection zone.
Inspection data is recorded for quality documentation. Automated sensors monitor fabric width and tension.
Approved fabric continues to final finishing. Rejected sections are isolated to maintain quality standards. Inspection continues until the full roll is completed. The machine slows as inspection reaches the end of the roll.
The inspected fabric is rewound evenly.
Edge alignment ensures uniform fabric rolls.
The inspected roll reaches its final diameter. Inspection labels are printed for traceability.
Inspection results are attached directly to the fabric roll.
The inspected fabric moves to the packing stage.
The inspected fabric roll is protected with industrial wrapping for storage and transport. Edges are sealed to prevent damage during handling.
Finished rolls are placed on pallets for organized storage. Pallets are transferred to warehouse storage, awaiting dispatch.
With inspection complete, the fabric is ready for delivery to the market.